Okay, 10.4 is going to talk about measures of central tendency. That's how things bunch up or how they're grouped as an average. And then also measures of variation, which is how far things vary from the norm, or what's standard, or what's the average. So the first thing we're going to talk about, and the portion we're going to talk about today, is the portion about central tendency, averages. All right, so the first one is the one that you mean when you say average. It's mean. So this is called the arithmetic mean, and it's found by adding all your values together and dividing by how many values you have. So if we wanted to know the average height in this classroom, I could find out from every single one of you what your height is. We could add them all together, and we could divide by 16 if we include me, because there's 16 of us. Okay? That's what you mean when you typically say average, isn't it? You're usually meaning the mean. But there's two other types of central tendencies, or averages. The next one is the median. The median is the middle value. So again, let's keep going with our idea of height. Let's say we took every single one of you in the room now and we put the shortest person over here up to the tallest person over here. Since there's 16 of us, that's a little bit awkward. So ignore me for the moment. There's 15 of you. And if we counted it off, there'd be one person in the middle. That's the median. Okay? Now, it's awkward when there's an even number of people. So if we have all 16 of us and we do the same thing, there are going to be two people in the middle. Agreed? So you take those two people's heights in the middle, or those two values in the middle, and you average those. That's how you find the median. So the median really is the middle point, the value of the middle point. Mode is the amount that occurs most frequently. Okay? So when we were looking at the data tables back in section 1, or well, it was called section 2, and we were looking at sort of the bar charts, the modes were the ones that had the highest bars on the bar chart. It's the numbers that occurred the most frequently. Okay? So a couple of things, and why in the world do we have multiple representations for things that mean the average? Well, let's say, for instance, we did our height example in the room, but we had someone in the room who was exceedingly short or exceedingly tall. They threw all of the numbers off. Well, if they were exceedingly short or exceedingly tall, and we averaged them, their number would sort of make things look a little funny. It would make us look either as a class as though we were quite tall, or at least taller than we really are, or quite short, just by that one value thrown in there being odd. Right? So Shaquille O'Neal comes in, we average his height, that's going to look weird. It's going to look like we're really tall, and we're really not exceptionally tall. It's just one person's height. Are you with me? So that's weird. I mean, that's an awkward arrangement. The other thing that can happen is, so if we took that situation and we had Shaq in here and we had us all lined up, if you took the person in the middle, it doesn't matter if you have that one person that's extremely tall. His height's not really making things look weird, right? Okay. Here's another thing with mode. Another time, or so a time when you've got an example where a median gets thrown things off is one of those sort of a weird, they call it an outlier, some value that's sort of not within the normal range of things. If you were looking at, say, for instance, the average salaries of your faculty and staff on campus, okay? Well, some of those faculty and staff salaries would throw things off in a really awkward way, right? The president, he makes more than most of us, right? I mean, and that makes sense. But his number averaged in would make things look a little bit funny, right? And if you were really thinking about faculty and somehow you averaged in the salaries of those people who are part-time employees who are, working at the Rock or something like that, some of your student employees, that would average things in a weird, awkward way too. Okay, so that's another one where it gives you an example. Mode being the number that occurs most frequently. So let's say, for instance, you were talking about salaries of the employees at, let's say, at Walmart, because there's a significant number of people working there at any one time. Most of the people on the floor make a certain salary, or within a particular range. I mean, right, it's pretty predictable. They make between this number and this number, whatever. But if the CSM, who's on top of all of them, right, the person who's like a head charge person, makes considerably more, it really starts to feel awkward that we include his salary or her salary in this arrangement, kind of like including the presidents or the part-time student workers in that faculty salary arrangement. So what you can do is you can actually look at the mode, that is, where do the most frequent number of people sort of fall? Okay, so this happens when people look at, well, I can't remember if this is an example in here, if it's in your homework, when you look at the prices of homes in an area, right? So if all of the homes in the area are pretty much around 100,000, and then you have Bill Gates' house in that area, or at least near enough by that it gets calculated in, that's going to throw things off a little bit. We kind of just want to ignore it because it doesn't really represent the majority of what's going on. So in that case situation, the mode, that is where most of the values fall, makes more sense to talk about. Are you guys kind of tracking with me on this? Okay. Calculating these is not difficult. All right, so how do you find mean? We'll start with mean. What do? You find the average. So you add them up and divide by the number of values that you have. Good. Okay, so I need to talk to you about how much work you need to show me. You have two options for mean. You can either write out 18. I'm going to write it out for this case, and then I'll show you your two options. How many values are there? 7. Okay. What do you get when you add everything together on top? How much? 139? Did I hear right? Okay. And what is 139 divided by 7? Okay, so we'll use, I have this written down, 1 decimal, so unless your book tells you otherwise, let's go with 1 decimal, 19.9 then. Okay, so you have two options. You can either show me this piece or this piece. I don't care which one you show me, but you got to show me one or the other. Okay? As part of your show the work step, it's got to be one or the other at minimum. You can't just tell me the answer is 19.9. And it's as much as anything for your own protection that you don't make some silly calculator error, because then I don't have a clue if you even knew that you're supposed to add things together and divide. So you're showing me that you know that you're supposed to be adding and dividing by doing that. Okay? Median. What do I have to do to find the median? Okay, I think I heard you say put them in order. I actually heard a lot of noise. Does put it in order sound good? All right, so what's my small? You can do smallest to largest or largest to smallest. What's my smallest value? 12. And then 17. And then? And then? And then? And then? And then? And that's it, right? Are there an even or an odd number of these guys? There actually are an odd number, which means if we sort of mark them off one at a time, working our way inward, we'll end up with exactly one middle value, 18. Okay, again, what do you have to show me? Well, you have to show me the numbers in order. And then circle the middle one. And if there's two middle values, you'll circle both of them, and then you'll show me the average of those two. Sound good?
Do you have to show in order, or could you cross out like the lowest and the top?
You could cross out the lowest and the top. You do run into a problem if you've got the data set too big, is that you might accidentally miss one, and then you're going to have to start over from scratch. So you could do that, Brendan, just be aware that if you do, you're going to need to be really careful to do it that way. And then we need the mode. And how do we find, what is mode? Let's start there. The most frequent. And if you've already put them in the order, then you should be able to identify that pretty quickly. Which one or ones occur most frequently? And when we have two of them, we write both of them down, and this would be then called bimodal. It's like bipolar, but this one's bimodal. Okay, and you can have more than one. You can have it trimodal. It could have 4 modes, and it could also have no modes. If everything occurs the exact same number of times, and or just nothing occurs more than once at all, it's just considered to have no mode, and you can write no mode down. Okay? All right. We're going to do a couple of examples that are, they're applications of these ideas is what they are. Example 2, the mean scores on a set of 20 tests is 75. What is the sum of the 20 test scores? How can I find that?
So you can multiply
Yeah.
75 by 20.
So if you multiply 75 by 20, that is the average score times the number of scores, you'll find this. And this comes from the whole idea of what this means. Let me write it as mean. Your mean is the sum divided by the number of, in this number of values. We'll say it that way. So if you take this formula, which is what it really is, and you rewrite it by multiplying by the number of values, if you take the mean times your number of values, you get back the sum. Make sense? So what is 75 times 20? 1,500. Example number 3 is just for you, Brendan. Are you ready? All right. If the mean weight of 7 linesmen on a team is 230 pounds, does that sound reasonable?
It's low.
It's low. Bummer. All right, well,
Depends on if it's O-line or D-line. Our O-line probably averages.
no. Does anybody know what he's talking about? Oh, we see. Oh, and then I heard offensive. Okay, I'm good with that now.
About 300 pounds.
Okay, can we do the problem with 230? Are you gonna be okay with that? Okay. All right. So we're gonna pretend that we have 230 pounds as their mean weight, and then we've got the mean weight of the 4 backfield members. Who are they? What does backfield members mean?
Depends on if it's a defense or offense.
Can you make one up for us?
Well, if it's offense, it would be the running backs or quarterbacks.
Okay, there we go. It's the running backs and quarterbacks, and they weigh less, don't they? Because they don't have to block the people. Good. So 190 in relation to my 230s, and you okay?
About right.
Oh, good. We got one of them about right. That's good. All right. So here's the deal. The question actually asks then, what do we do to find the mean weight of the 11-person team? And let me just tell you right now, we don't add 190 and 230 and divide by 2. It's not going to work. Why?
Because there's more of one than the other.
There's more of one of them than there is the other, right? So somehow we've got to take that into account when we find this new mean weight. How are we going to find this new mean weight?
Find the sum of all the linesmen and the sum of all the backfield members, and then add those together.
That sounds like an awesome idea. So we're going to do the sum of the line. We're going to find the sum of the backfield. And then, well, let me do that steps first, and then you can tell me what to do next, Lauren. So how do we find the sum of the line?
Multiply by 7.
Okay, the 230, right? Okay, so we're going to multiply the 230 by 7, just like in example 2. And what are we going to get?
261. Or no, 251.
It's got to be bigger than that.
Oh, sorry.
What'd you get, Heather? Oh, somebody got
I'm
one?
missing a number.
1610.
Yeah.
I heard that a couple of times. Okay, 1610. And then we're going to do the same thing with the backfield, right? So that was 190 pounds. And we had 4 of them? Okay, so what about 190 times 4?
76. 760.
760? All right. Now what?
Now we add those together and then divide by 11.
You got it. All right, so now we're going to find the mean of all of these 11 players by taking the sum of the linesmen, which was 1610, plus the sum of the weights of the backfield, which is 760, and dividing that by our 11-person team. So 1610 plus 760, and then divide by 11, what do you have?
215.5. About.
And what would we write next?
Oh, wait, what?
Pounds. Somebody said it loud enough for me here. My hearing's not good, you guys know. All right, pounds. Yes, this is pounds. If you change it to 216, that's okay. I mean, we're finding an average. It's okay. But your work should still support these pieces, right? And then if there's any indication given on how you should round, of course, follow those directions and round appropriately. Okay, any questions on this? Okay, the next part of this section is all about the variation portion. Okay, so we finished the central tendencies part, so this is the natural stopping spot, which is good because then you'll have time to do back the group work from the last section.